Okay, so have you ever wondered what happens when artificial intelligence gets so incredibly smart that it starts inventing math we humans can barely even understand? I mean, who or what is going to check its work? It's a huge question, right? Well, let's dive right into this. Welcome to today's Data-Driven Explainer. Today we're looking at this fascinating intersection of AI, future forecasting, and the world of advanced mathematics. And we aren't just talking about vague, abstract theories here. We're going to break down a highly specific, time-stamped prediction about exactly where mathematical science is heading over the next decade, and how we might just keep AI on a leash.
Here's our roadmap for today. First, a welcome to Creation Unified. Second, the UIM impact forecast. Third, future validation markers. Fourth, confirming the forecast. Fifth, conditions for falsification. And finally, number 6, independent verification. Let's get right into it.
Section 1. Welcome to Creation Unified. Introducing the framework. First off, I want to formally welcome you to Creation Unified. The research we're exploring today is provided by Kevin L. Brown. He's the founder of Creation Unified and the author of Unified Informational Mathematics, or UIM for short. Now, if that term sounds a little intimidating, don't worry at all. Simply put, UIM is a proposed system for measuring and mapping information within math itself. It's kind of like a specialized language for tracking exactly how mathematical proofs are built. This explainer is actually part of an ongoing series featuring AI remote viewing sessions. The goal here is absolutely super cool. We want to build a public archive of time-stamped, verifiable tests. That means you can use these exact predictions to validate this research as the future actually unfolds. Moving to Section 2. The UIM Impact Forecast, measuring the future of math. So the absolute core of this explainer comes down to one central question. How does UIM actually materially influence mathematical science through the year 2036? And if it does have an impact, when will it happen, how will it happen, and what exactly will that footprint look like? Look, in today's world of AI hype, where a new game-changing model is announced literally every week, we aren't looking for open-ended guesses. We want a highly specific, measurable footprint in the real world. And why the year 2036? Because true, serious scientific frameworks need hard deadlines to prove their worth. Setting a concrete timeline is what separates real mathematical forecasting from science fiction. Let's look at how this timeline actually plays out. Right now, in the present day, the UIM framework is fully established. Between the years 2028 and 2033, the forecast predicts UIM is going to begin having a measurable physical impact. But here is the really interesting part. It won't be by solving giant, famous, unsolved math problems right out of the gate. Instead, it'll be adopted for something called proof governance. Think of proof governance like a superpowered spell checker or fact checker for ultra-complex math. As AI generates massive, complicated proofs, we desperately need a reliable system to make sure it isn't just hallucinating structural errors. Then, moving from 2033 to 2036, the forecast predicts broader recognition of these methods, assuming, of course, the framework survives intense testing.
Section 3. Future validation markers. Tracking the 14 data points.
To know if this forecast is actually true, we need exact, undeniable markers. So we're going to look at 100% of the predicted data points right now. Here are the first 5 out of 14 events, and they really tell a story of how a new idea catches on. First, an independent researcher has to engage UIM substantively, meaning they really dig into it, not just a passing comment. 2, UIM has to be cited externally in scholarly work. 3, we need to see external use of its preservation framework. 4, a formal proof graph is built using UIM concepts. And 5, structural proof pressure is quantitatively tested. In plain English, that just means testing the absolute limits of a mathematical idea with real numbers to see exactly where it breaks under pressure.
Let's move on and see how this builds momentum from pure theory into actual usable tech. Marker 6 predicts the first real-world test yields measurable results compared to simple baselines. 7, the original metric is refined and improved by others. 8, independent researchers reproduce or extend UIM theorems. 9 is a big one. UIM concepts are directly used in AI theorem proving. And 10, an actual computational tool or software system implements UIM bridges. This is that massive leap from ideas on paper to real code inside a machine.
Finally, the last 4 markers show the complete shift to wide acceptance. 11, UIM is actively discussed for heterogeneous or widely varied math domains. 12, a landmark math study is used as a real audit framework. 13, an external group actually adapts UIM terminology as their own. And 14, UIM gains a recognizable scholarly footprint by that closing window of 2033 to 2036.
By that point, it's a recognized standard. Every single one of these 14 points is a specific, verifiable event for us to watch for.
Section 4. Confirming the forecast. What success looks like. Now, in any strict scientific forecast, we need to know exactly what counts as a win. A strong confirmation requires independent citation, actual use by others, and quantitative testing. But an exceptional confirmation goes way further. It's basically the difference between hitting a home run and winning the whole World Series. Exceptional confirmation means multiple independent groups are using it, there's widespread software use, and the framework actually diagnoses real, critical failures in mathematical proofs out in the wild. Section 5. Conditions for falsification. When the forecast fails. Real science absolutely must be falsifiable, meaning it has to be possible to prove it wrong. This forecast is a total bust by 2033 if any of these 10 specific conditions happen. The forecast fails if there's no independent engagement, no external citations, or no outside implementation. It fails if proof pressure doesn't beat trivial predictors, if the metric needs retrospective tuning, which is just a fancy way of saying moving the goalposts to make the data fit, or if the representations are unstable. It also fails if existing math is sufficient, if it cannot be operationalized into code, if it's dependent on specific language mainstream math won't touch, or if it's regarded as a mere reformulation of old ideas. 10 clear ways to fail. And here is the hard deadline. By the end of 2036, the forecast is completely rejected if UIM produces no independent scholarly lineage, no external implementation, and no meaningful AI use, period. Having a strict expiration date like this on a theory is a sign of real integrity. It's a very clear line in the sand. Section 6. Independent verification. The viewer's role. I want to read this quote from the source material because it's absolutely vital. The most important part of the scan is that the impact path is narrower than the title. The first credible foothold is proof, governance, and AI-era mathematical verification. Basically, UIM isn't trying to magically rewrite all of math overnight. Instead, it's aiming to be the ultimate auditor for AI when AI does math. It's all about securing the foundation before we try to build the skyscraper. So, this brings us to a really crucial validation notice. These remote viewing markers we just went through, they're raw data points. They are predictions, not facts. The power here is entirely in your hands. You need to independently verify and validate these markers using public information as the future actually unfolds. Don't just take our word for it. Watch the world of math and AI closely and check the facts for yourself over the coming years. Before we wrap up, I just want to leave you with this thought. If artificial intelligence can eventually solve math problems that we humans can't even comprehend, who will be left to verify if the AI is actually right? Could frameworks like UIM be our only real safeguard against a machine's mistakes? Thank you so much for joining me for this explainer. AI is rapidly changing how we verify truth, and it's going to be fascinating to watch this unfold. To explore Kevin L. Brown's research or to try the free AI remote viewing tool for yourself, please visit creationunified.com. Keep learning, keep verifying, and I'll see you in the next explainer.